Hi, this is Gunasekaran, Assistant Professor of Mechanical Engineering at SN Institution. Now we are seeing about introduction to overhanging beam. Okay, overhanging beam. Structural components known as overhanging beam. Sticks past the support to produce a cantilever effect. Okay, they offer design flexibility and load bearing capacities and are frequently utilized in bridges, buildings and other technical applications. Okay. Okay, definition. An overhanging beam is a structural element that is supported at one or more points along its length and extensions beyond it supported at one or both ends. This configuration allows part of beam to overhanging freely, creating cantilever effect at the ends. Okay. Some supported points. The beam has one or more supported places within its span, leaving one or both ends to overhanging freely. Bending moment is occur. Experience bending moment due to a load which can vary throughout its length. Okay. The overhanging portions experience moment in the opposite direction of this span. Okay. Shear force occur throughout the beam length. Influenced by the portion of supported and loads. Okay. Then deflection. The beam will deflect under applied loads, particularly at the overhanging ends. Okay. Then we are seeing multiple loading screeners. Okay. Overhanging beam can be subjected to point load, distributor loads, or a combination of affect the structural behavior. Okay, overhanging beam are commonly used for structural design for balconies, bridge, also building overhanging. Proper analysis is curious to ensure the beam stability and safety under various allowing loading conditions. Okay. Then we are seeing assumption and simplifications. When analyzing and design overhanging beam, engineers often use certain assumption and simplification to streamline the process and obtain accurate results. Okay, first one, linear elastic behavior. The material of the beam is assumed to have in a linear elastic manner, meaning it will return to original shape when it is a rod is removed. Okay. This assumption simplifies the analysis and the calculation of stress and deflections. Uniform cross section. Overhanging beam are typically assumed to have a uniform cross section throughout their length. Okay. Providing consistent structural properties such as a movement of inertia and cross sectional area. Okay. Type of loads load on the beam are often assumed to be either concentrated at specific point. Okay, point loads are uniformly distributed along its length. Okay, no self weight and fixed support. Then two-dimensional analysis, static loading, no lateral torsional buckling. By making the assumption and simplification, engineers can focus only aspects of the beam performance. Okay. Now, deflection calculation. Deflection calculation for overhanging beam involve determining how much the beam will bend under applied loads. This is crucial for ensuring the structural integrity and performance of the beam. Okay, the deflection can be calculated using formulas derived from the beam theory, such as the Yeah, earlier Bernoulli's beam equations, and which related the bending moment allowing the beam to its deflection. The beam deflection depends on factors like the type and position of the loading, the beam length and material properties such as the Young's models and its bending moments. Okay, thank you.